We've been looking at various aspects of Entity Framework Core, and I thought that this week we'd move on to looking specifically at relationships and the way that we model relationships in C# in code and how that maps onto the database. Now, I've already seen a little bit of this with some fairly straightforward many-to-one relationships, but let's look at this in more detail. And let's start out by looking at the actual theory of how all this works. So what I'm going to do for these examples is we're going to have 4 entity classes that model the way some kind of school or some kind of college works. So we've got a student, we've got a teacher, we've got a classroom, and we've got a course. And if we just think of the way that those entities relate, we can see some various examples. So to start with a simple one, the relationship between a classroom and a teacher is what we call a one-to-one relationship. So at any particular time, a classroom contains one teacher, a teacher is in a single classroom. So that's a one-to-one relationship. Next one up for that is what we have as a one-to-many relationship. One-to-many relationship we might have with the relationship between a classroom and students. So a student is in a single classroom, but a classroom can contain as many students as its maximum capacity may say. We don't really worry too much about that, we just call that many. So that's a one-to-many relationship. And then lastly, the third kind is what we have as a many-to-many relationship, and that's what we'd have, say, between courses and students. So a student is subscribed on several courses, a course is followed by several students. So that's many-to-many. And then one slight further complication on that is in any of those situations where we have a 1 at either end, so one-to-many or one-to-one, we've got to actually ask the question, is that an obligatory part of a relationship? So are we saying that a classroom has exactly 1 teacher, or could a classroom have 0 teachers if it was empty? Similarly, could a teacher not be in a classroom? And I think in that example, we can see that we do want it to be optional. And so we typically call that a 0 or 1-to-one, or a 0 or 1-to-many. So that's the slight variant we've got there. Now, when it comes to C#, this is all done in a pretty straightforward way, or at least I think it's straightforward, because I'm a software developer, I write in programming languages. If I were a DBA, I'd probably think of it as natural in the way the databases do it. So with the C# way of doing things, for the many, we simply have a collection. So a classroom would have a collection of students, and for the 1, we just use a reference. So a student would have a reference to their classroom. In terms of the 0 or 1, actually that's something that traditionally in C# has been quite tricky to directly model. But as of C#8, now that we've got nullable and non-nullable references, a nullable reference is the 0 or 1, and a non-nullable is the exactly 1. So if you want to look at my previous video on that, there's a link to it there, and you can have a look at how those work. But now let's see how those C# ways of doing things map onto the relational database when we're using Entity Framework. Here in the code then, I've got my classroom, I've got my course, I've got my student, and I've got my teacher. And at the moment, there are no relationships between any of those. And then I've got this training context, my DB context, that just declares all of those. And then in the program, I just make my connection to the database, which is a SQL Server database, do the ensure deleted, ensure created. So every time we run this, it's going to create a new database schema based on the changes I make to the entities. And then finally, and I haven't filled this in yet because it's not going to work, but we've just got some mock data so we can see, once this is done, how it'll all fit together. So let's just run that and just see what's created. So if I run that up and then go to SQL Server and refresh that, and there we can see our training DB. And if we look in the tables, we've got just the 4 classes there. But if we look at any one of them, there are no relationships between those as yet. So now let's add the first one of those. And it turns out that actually the easiest one to do is the one-to-many. So let's do that first. So let's go to our classroom, and in here, let's just add a collection of students, call that students, and then now if we run that up again, we can see immediately in there that our classrooms actually hasn't changed, but it's on our students that it's put a foreign key called classroom ID. So that's one of the big differences philosophically almost between the way that we do it in C# and the way that we do it in databases, that in C# it's the classroom that knows about the students with a collection of students, whereas in the database, it's the student that knows about the classroom through the classroom ID. But that's all mapped for us. We don't have to worry about that. Entity Framework understands that and smooths out those differences. You'll notice if we see in there that classroom ID is nullable. That means that what we've actually got here is a 0 or 1 to many. So a student, as we can see there, could not have a classroom at all if they were out in the corridor or whatever it may be. If we want to change that to exactly 1, we actually saw earlier on a couple of ways to do that. One way we can do it is to use the C# 8 feature of making it a non-nullable reference. Essentially, the way we need to do that is we need to go into the student class itself. So if we go to the student class, and then on here, simply put the reverse reference. So here I'm going to have a reference to a classroom, and let's just call that classroom. And as that stands, that's not actually going to make any difference because obviously a reference in C# can still be 0 or 1. The way we can change that is either we could use C# 8 and then that would become a non-nullable reference and we'd have to specifically put the question mark on there to make it nullable. Or the other thing we can do is we can simply use the attribute. So if we put required on there, so now we're saying that a student has to have a classroom. And so if we run that again, now we can see it's changed that so the classroom ID is not nullable. So a student has to have a classroom and a classroom can contain several, as many as you like, students. So that was our one-to-many. As I say, that's the simplest one. Let's now look at a one-to-one. So let's go and look at our relationship between a classroom and a teacher. So here I'm going to put just a teacher, and let's call that teacher. Now, as that stands, that's not really given the system enough information to figure out what's going on because that could equally be a teacher having several classrooms or a teacher having a single classroom. So what we also do is go onto the teacher. So as well as saying a classroom has a single teacher, we're going to say a teacher is in a single classroom. But immediately we do that, we actually get an error when we try and run that and generate the database schema. The problem being that when you've got a one-to-many relationship like we had between classroom and student, it's absolutely obvious where that foreign key should go. The foreign key, as we saw, goes on the one end of it, so the student gets the foreign key into the classroom. But when we've got a one-to-one relationship, that could be done either way. We could do that by having a foreign key on the classroom into the teacher or a foreign key on the teacher into the classroom. And it's completely balanced. There's no obvious way to infer that. So what we have to do, well, a couple of ways we can do it. The way I would normally go is if I decided that it was going to be the teacher that contains the foreign key into the classroom, then I would simply put that foreign key on there. So here we would have an int because that's what my IDs are. And then I would simply follow the convention that we talked about in the earlier videos, which is to use the property name plus ID, so bottom classroom ID in there. We can now see when we run that up that that's worked okay. And so now if we take a look at our teachers table, we can see that teacher has that foreign key into classroom. And we can also see that that classroom ID has not allowed nulls. Now, the reason it's done that is because I declared that as an int. Int is a non-nullable type, therefore it can contain nulls. But conceptually, what that means is that every teacher must be in a classroom. It doesn't mean every classroom must have a teacher, but it does mean every teacher must be in a classroom. And again, if I want to change that, I can simply, easiest way is make that a nullable integer. And so now when we run that, and then look at the database again, there we can see we've now got a nullable classroom ID. So a teacher doesn't have to be in a classroom, there can be somewhere else entirely. So we've done 0, 1 to many, we've done 0, 1 to 1, and now let's look at many to many. Now many to many is where databases do things in a very different way because databases don't really understand collections directly, and so that's why with a one-to-many we do it with a foreign key, but a many-to-many is going to be tricky. In C# terms, it's easy. So let's do the one we talked about. We were going to say that a course has several students. So we'll do an I collection of student, called students. And also a student is on many courses. So let's have a I collection of course called courses. So straightforward enough, that gives us in C# terms many-to-many by having the two collections. Let's see what happens when we run that up. And if now we refresh the entire database, we'll see that what it's actually done is added a further table that it's called course students, so made up of the names of those two entities. And this is an entirely standard way of doing things in relational databases to have many-to-many relationships. This is what is known as a correlation table sometimes, or a lookup table, or whatever you like. If we take a look at the structure of it, you'll simply see that it's got one column for a course ID and one column for a student ID. So every relationship between a course and a student will have a particular value in there. It's probably useful with these lookup tables actually to pop some data in there so we can really see what's going on. So let's actually do that. Let's go back to our program, and then in here, let's uncomment all of that. And just one little bit that's not in there yet. So let's comment that back. But the rest of it, you can see we've created a couple of teachers, a couple of classrooms, a couple of courses, 6 students, and then we are saying, this is what we're looking at here. So our course 1 has students 1 to 4, and then our course 2 has 3 to 6. So that gives us the many-to-many. So if we now run that one, that won't change the database schema, but it will actually give us some data in this lookup table. And if we take a look at that now and actually look at the contents, so let's look at courses. And so there we've got our 2 courses. Let's look at students. So there we've got our 6 students already put in a classroom. But then if we look at course student, we can see what's going on here, because we're saying there is a relationship between course number 1 and student number 1. So that means that student number 1, Jenny Jones, is in course number 1, Introduction to EF Core. And we can also see that student number 2 is on course number 1, but we can see that, say, student number 3 and number 4, they are both in course number 1 and course number 2. So there we can see how the many-to-many works. But the thing to notice in C# terms, we don't get an actual class for that, because that course student table is purely there to make the many-to-many relationship work. Well, we don't need that to make it work in C# because we've got the reciprocal collections. This, again, is one of those things that it's defaulted quite sensibly on the name for the table. Because the 2 entities are called course and student, it's called a course student. There are ways to do in the configuration. I'm not going to go into the detail, but you can specify that to have a different name if you want to. But as I've been saying in previous videos, why change things from the default if the default is okay? One other thing to look at, getting back to one-to-many relationships, a slight complication of that is the situation where you have relationships with different roles. And the example we've got here is when we have a course, let's suppose that a course to be written has 2 teachers involved, one of whom is the author of the course and one of whom is what we'll call the editor of the course. So just to check for mistakes and that sort of thing. And that means that any particular teacher could be author on several courses and also could be editor on several different courses. So let's code that up, and let's do that by putting in the teacher the idea that there's going to be a collection of courses, and we'll call this courses written, and then there's going to be another one called courses edited. Okay, and if we run that one up, it works okay. But if we take a look at the courses table, we can see what it's done. As you'd expect, it's put in 2 foreign keys, both into the teachers table. But it's not been clever at all about what the names of those foreign keys need to be. It's just called it teacher ID, which was the default we saw for your one-to-many relationship. But then for the other one, it's just come up with a brilliant name of teacher ID 1. And if you leave it like that, you will end up not very long from now in huge amounts of confusion trying to think what the meaning of those particular columns is. Obviously, if you do it entirely through C#, you never see that, but at some point you're going to look in the database and you're going to be bewildered as to what the difference is between teacher ID and teacher ID 1. So we can fix that, and we actually know how to fix that because the easy way is just to use the attribute of foreign key. And so the foreign key on this one, we can call this author ID, and on the other one, we'll call that one editor. And so now if we run that, and close that down and refresh it, now we can see it's doing exactly the same sort of thing, but much easier to read what's going on in the code that we've got there. One final thing we might want to do in that is actually have the relationship in the other direction as well. So at the moment, although our teacher has the 2 collections of courses they've written, courses they've edited, we don't have on the course anything to get back. So we might want to have that. So the way we do that, naturally enough, we could have teacher, and we might want to call that one author, and on that one we might want to call that one editor. And you might hope that because those are called author and editor, because the foreign keys are called author ID and editor ID, that it will work out following the conventions that all makes sense. But sadly it doesn't. It gets confused at this point. There's a clash between those things, and this is actually something that we've got to resolve using the Fluent API, which we saw last time. So let's do that. Let's go into our training context, and as ever, when we want to start using the Fluent API, we do an override of on model creating, and then we take our model builder, and what I'm going to do here is say model builder, get hold of the entity for course, and then we've got to say dot has one, so a course has a single editor, let's say, and so we'll do C gives C dot editor, and then we reverse that by saying with many, so that's going back in the other direction. And so here we say T for teacher, because that's what the type of this is, gives T dot courses edited. So that sets that back in the other direction. We in fact saw in the earlier video I was doing this and it wasn't really necessary. It wasn't necessary when we only had the one relationship, but now we've got the multiple relationships, the multiple roles, we've got to do that. And then we can just duplicate that for the other one, because we know that a course also has one author, and that comes back through courses written. And so now, if we run that up, it's now happy with that. It hasn't really actually made any change to the code here, because structurally the database is exactly the same, but it has now allowed us to have that relationship working in the C#. And if we just go back to our program and remove that one last bit of comments we had, so now we can see that we're making, on our 2 courses, we're just swapping around the 2 teachers as to whether they're author and editor. But if we run that one up now, and if we take a look at our courses data, then you can see that we've got the appropriate IDs in the author ID column and the editor ID column. And if we go back to the program, if I just put a break after I've submitted all that to the database, so let's run it up to there. And then if we look in the database and look at the collection of courses, we can see, if we look at the results there, so there's our first course, and it's got an author and an editor. And then if we look at the author, we can see that the author has the reference back to the courses edited, the courses written, and so that's working both ways in terms of the relationship. So that was it for our relationships in Entity Framework. We looked at the one-to-one, we looked at the one-to-many, we looked at the many-to-many, all of those which can be handled perfectly straightforwardly, just writing a C# code and letting it follow the default rules. And as I said, that's what I normally do. Although everything can be modified, you can change the name of your columns for your foreign keys, things like that. We've seen most of that in earlier videos. We can either use attributes or we can use the Fluent API. There's a bit more as well that we can do, but that's something you can look up for yourself. The only time you needed to do that, I would say, that you really don't get a good database was once we had that idea of our relationships with roles, where we had teachers being both authors and editors. And that was the first time where it was really essential for us to start intervening with, in that case, actually a combination of attributes and the Fluent API, though we could have done it all in the Fluent API. Next time, we're going to look at a completely different type of relationship, but a very important one in C# and object-oriented programming. We're going to look at inheritance and see how that can really quite easily be mapped onto a relational database. So do like the video, do subscribe, and I'll see you next time.